Hey everybody, we are working on factoring quadratic trinomials and binomials today. This worksheet follows an in-class assignment that we did, which looks kind of like this. So if you missed class today, then the first thing you're going to want to do is go look at this assignment. Because if you don't, this assignment is going to be really confusing. So let me see if I can explain how these go together. In this assignment, the first 12 problems are multiplying problems. So notice we have binomials that we're multiplying. And there's 12 of those. Okay, first 12 there. Now I've used a couple different methods here. I've used the FOIL method on the left side, and I've used the box method on the right-hand side. So it's up to you which method you want to use, but these are two methods that we talked about in class for multiplying a binomial times a binomial. So this stuff here on the in-class assignment isn't new. This is actually something that we started doing on Monday. I think it was Monday. Maybe Tuesday. So what we're doing here is we're just foiling or using the box method to multiply two binomials, and we get these results. Now the goal here for this assignment was to actually figure out how to factor, which is like the inverse. So multiplying is going from factors to product. Factoring is going from product back to factors. Okay? So our goal for our homework assignment is actually to start here at the end, at the product, and be able to work our way backwards to the original factors, basically unmultiplying. So it turns out that in order to factor, it helps out if you multiply a lot and then you look for patterns. So there's 12 problems here that I wanted you to multiply through, and as you do that, you'll start to recognize some patterns about the results here from this guy. For example, this number, for a lot of these result in trinomials, so this guy, this guy, this guy, this guy, this guy, this guy. Most of these are trinomials. Okay? What you'll notice is that this term, the linear term, the coefficient comes from the sum of these two numbers, 3 plus 9. The constant term at the end is actually the product of these two numbers, and that pattern actually holds out through all of these. So like if you look at number 5, for example, 2 is the sum of 11 and negative 9. Negative 99 is the product of 11 and negative 9. Okay, over here, same thing. 18 is, or excuse me, negative 18 is the sum of negative 8 and negative 10. 80 is the product of negative 8 and negative 10. So understanding those patterns will help us to do this assignment, because in this assignment we're doing the exact opposite. Instead of starting with two binomials and ending with a polynomial of degree 2, we're starting with a polynomial of degree 2 and we're working our way backwards to the factors. Okay, so these actually go along with each other. They kind of are like mirror images of each other, right? This has 12 problems where you're multiplying. This has 12 problems where you're unmultiplying. So super helpful. Make sure you do this one first. If you were in class, you did it already. If you weren't in class, though, you're going to want to look at that. And I've posted this assignment along with the entire answer key in Canvas for you. Okay, so let's start with these guys. Now, this is basically some inductive reasoning here. When I multiply two binomials that are linear, many times, most of the time, I end up with a quadratic trinomial. In other words, I have something that's degree 2 with 3 terms. Okay? So we're going to use that idea here. We're going to start here and we're going to say, okay, this is a quadratic trinomial, so based on our experience, based on our observations, it probably came from multiplying two linear binomials. So I know that I'm going to have n plus something and n plus something here, because when I multiply n and n, I'm going to get n squared. Okay? The trick is, how do I figure out what numbers go here? Well, based on the patterns that we saw in this assignment, we know that these two numbers have to multiply to give me this guy. We also know that those two numbers have to add to give you this guy. So what you can do is you can start listing the factors of 16 as pairs, right? So we can prime factorize this. That's one way to do it. But we also, in this case, we want to look for factor pairs. So like 1 times 16, for example. 2 times 8. 4 times 4. right? Those are all factor pairs that will give us a 16. Why do we care about that? Well, because remember, these two numbers have to multiply to 16. So, of those pairs, we have to look for the two that not only multiply to 16, but that also add to give us a 10. If I add these two together, I get 17. If I add these two together, I get 8. These are the two, this is the magic combination that will give me a 10. So I need n plus 2 and n plus 8, and that's my factored form. Okay. Now, if you wanted to double check, you could FOIL this to see if that actually worked out, right? So this is the answer, but as a check, we can use our box method or our FOIL method to make sure that we actually got the right thing. So off to the side, kind of small here, I'm just going to write my, my terms here and see what I get. So in the top left corner, n squared, top right, 8n, bottom left, 2n, and bottom right, 16. Sorry, that's kind of small. I'll write it bigger on the next one. But altogether, that was an n squared plus an 8n plus a 2n plus a 16. So now you can see, oh yeah, these two are going to combine. When I combine these like terms, I'm going to get a 10n, and when I multiplied them, I got a 16. Okay, so this isn't the answer. This is just checking the answer. Okay, what we're trying to do is we're trying to start at the end and go back to the beginning. Basically, the exact opposite of what we're doing here. We're going to start with the product and see if we can work our way backwards to get to the original factors, and that's called factoring. Okay, let's do a couple more. So for number 2, we know, again, just by experience, just from our observations doing this assignment, that this quadratic trinomial probably came from 2 linear binomials, because that's what we saw in our work. Okay, we also know that these two numbers have to multiply to an 88. Okay, so they got to multiply to 88. The other thing that's interesting here is they have to combine to be a negative number. So we got to think of our options. If we are getting a positive number by multiplying two things, there's two options. When I multiply a positive number and a positive number, the result is a positive number. When I take a positive number and I multiply it by a negative number, the result is negative. If I take a negative number and multiply by a positive, the result is also negative. If I take a negative number and multiply it by a negative number, the result is positive. Okay, that's really important to know to figure out what these terms are, okay? So if my end result is a positive number, that means either these two terms are both positive or they're both negative. So I could have like a plus plus in here, or I could have a minus minus in here, right? Both of those will result in a positive 88, or a positive number, I guess, okay? Now the tricky part here is that when I add them together, it has to be a negative number. If these were two positive numbers and I added them together, I would never get a negative number. So the only option is that both of these numbers in here are negative. They have to multiply to a positive, but they have to combine to be a negative number. So they have to be two negatives, okay? Now the next step is to start looking for factors of 88, because remember, we have to multiply to get 88. So I'm just going to list some out, okay? I can do 1 times 88. I can get 2 times 44. I can have 4 times 22. 5 doesn't go in, 6 doesn't, I don't think 6 goes in. So I'm just kind of like experimenting here, but I think the magic numbers that I'm looking for are 8 and 11, okay? So remember, they both have to be negative. So let's do 8 and 11. But they also, and so what if I multiply a negative 8 times a negative 11, I get that positive 88. But they also have to combine to give me a negative 19. So if I do a negative 8 plus a negative 11, that gives me a negative 19. Okay, it can't be these two numbers, because if I do negative 4 and negative 22, I'm going to get negative 26. And it can't be these two numbers, because if I use those two, I get negative 46, and these ones give me negative 89. So it has to be the two numbers that will multiply to this, but when I combine them, I'll get this. And this is the only combination. These are the only two numbers that will multiply to a positive 88 and will combine to a negative 9, and so those are the two numbers in my factors. Okay, so factoring is a little tricky because you're going backwards, and you kind of have to think about, you know, about what numbers will multiply to this. So it's a little bit of guess and check, but the more multiplication that you do, like we did over here, the easier it's going to be to go backwards. Okay? Okay. I also wanted to show you a cool trick for kind of for practicing or for keeping track of your numbers. So we're going to skip 3 for right now, but we'll come back to that. And let's do number 4. Okay? So one of the ways that we can kind of keep track of our numbers, we know that we're going to have like an x and an x, right? What we can do is we can make this like little cross thing. And this is actually just a way to kind of experiment in a quick way. So what I do here with my little x is I put this number up here, and I put this number down here, and then I just start experimenting. Okay, so the two numbers that go here, this is again just to keep track of my work. It's the same thing we talked about, but these, when I put the numbers in here, these two numbers have to multiply to give me the top number, and they have to combine to give me the bottom number. Okay, so let me show you how that would work. I'm just going to test some stuff out here. So let's say I need numbers that multiply to 7. So let's say I do 7 and 1. Okay, so 7 times 1 is 7, check. 7 plus 1 is 8. Okay, that doesn't work. So I need to try some other numbers. What if we try negative 7 and negative 1? Negative 7 times negative 1 is positive 7, check. Negative 7 times negative 1 is, negative 7 plus negative 1 is negative 8. So these two numbers are the magic numbers. They multiply to give me the top one, and they combine to give me the bottom one. So just kind of quickly, I can see, or I can test which numbers it's going to be. Now going back and looking at these signs is actually a lot of hints as well. These will help you out. Remember, if the last number is positive, that means either both of these numbers are positive or both of these numbers are negative. Going back to our little chart here, the only way I get a positive result is if the two things are both positive or the two things are both negative. So just by looking at that last number, either these two numbers are both positive or both negative. Now how do I know that they were negative? Well, when I add them together, I have to get a negative 8. And if they were both positive and I added them together, I wouldn't get a negative 8. I'd get a positive 8. So there's just kind of some techniques here. Sometimes it's a little bit of guesswork, but as you practice, you get a little bit better. Okay, now if you look at this assignment, you'll notice that 3 and 8 and 11 are all kind of similar. And we're going to go back and talk about those later. Right now, I think I want to stick to the trinomials, the ones with 3 terms, because that's kind of what we're practicing, and I want to give you some experience with that. Okay, let's take a look at number 5. Okay, so I know my final answer is going to look like this. Just from experience, just from this assignment. I know that when I have a result that's a trinomial quadratic, then it probably came from 2 linear binomials. Okay, and I have an n and an n because that's going to get me an n squared up in the front. Okay, the next thing I know is that these two numbers have to multiply to 45. They have to multiply to positive 45. Okay, so that means those numbers are either both negative or they're both positive. That's the only way I can get this to be a positive. Since this number is negative, I know that they both have to be negative. There's no way that these can both be positive and add to a negative number. So I've narrowed it down to two negative numbers. And I also know that those numbers have to multiply to 45 and they have to combine to negative 14. So I'm going to put my little cross thing here, right? And again, this is just a technique to keep track of things. You don't have to use this technique, and there's other ways to do it. But what I'd like to do here is I put the 45 in the top and the negative 14 in the bottom, these two numbers. So whatever goes here, I'm going to test to see if they multiply to this and if they combine to give me this. Okay, so think of some numbers that multiply to 45. Well, 45 and 1 both do, and also 9 and 5. So if I try 9 and 5, that might work. Now remember, I just said a minute ago that they both have to be negative. So let's try this. Negative 9 times negative 5 is positive 45. Check. Negative 9 times negative 9 plus negative 5 is negative 14. So these are the two magic numbers that I need, a -9 and a -5. Okay. Now, if you wanted to check to see if you have the right answer, you can always FOIL or distribute or use the box method, right? So let's just double check. N times n would be n squared. We're going to have this, that's the f in FOIL, first terms. Then we have the outside terms, -5 times n. Inside terms, -9 times n. And then the last term is -9 times 5. So do these two like terms, sorry, that's a 5, combine to give me -14, n? They do. So if I were to multiply this back out using the box method or using the FOIL method, I get what I started with, so I know this is the right answer. Okay, now this one has a minus in the end, and that's kind of interesting. That's a little bit different. So what I'm going to do here is I'm going to set up my binomials. I'm pretty sure it's going to look like this, just based on experience, based on our in-class assignment. We call that inductive reasoning, seeing a bunch of examples and then looking for patterns. Okay, but this time, these two numbers have to multiply to this negative number. So this last number here, these two numbers will multiply to that guy. And the only way we get a negative number as a result is if the signs don't match. In other words, I have 1 plus 1 minus, or 1 minus 1 plus. So because the result is a negative number there, I know for sure that these signs don't match each other. I don't know what the numbers are yet, but I know one has to be positive and one has to be negative. That's the only way I'm going to get a result of -42. The other thing I know is that when I put these two numbers together or combine them, the result is negative, which means whatever these numbers are, the negative one has to be what we call a bigger magnitude, right? It has to be like the bigger one that when I put them together, it like wins. For example, if I have these two numbers right here and I combine them, the result is negative because the -7 is like farther from 0 than 3, or like the absolute value of -7 is bigger than 3. In other words, it overpowers the 3, and so my result is going to be negative. So I have a negative number and a positive number that when I put them together results in a -1. Think of this as a -1, which means this one has to be the one that overpowers this one. So it has to be, its magnitude has to be bigger, or its absolute value has to be bigger than this one. So that's helpful information. Okay, I'm going to set up my box. I want a -42 and a -1. Okay, so I'm looking for numbers that when I multiply them, I get -42, and when I combine them, I get a -1. So let's try some stuff. Let's try 21 and 1. Okay, sorry, 21 and 2, excuse me. If I multiply these, I don't get -42. Okay, I forgot one of them has to be negative, so let's make one negative. Okay, now -21 times 2, when I multiply them, is -42. All right, cool. But when I combine those, I don't get a -1. I get a -19. So that's not going to work. Okay, back to the drawing board. Let's try it again. Okay, here I have a 21 times a -2. That will still give me a -42 when I multiply them. When I combine them or add them together, I'm going to get a 19, not a -1. So it's not 21 and 2. Those are not the magic numbers. So what else can I multiply to get to 42? How about 6 and 7? Okay, now remember, one's positive and one's negative. So let's try a negative positive like this. -6, +7. When I multiply those two guys, they're going to give me a -42. When I combine them, I'm going to get a +1. Okay, I'm getting closer. That's not what I want, though. So let's finish it off. I think this last combination will work. Let's try +6 and -7. Okay, multiplying those will give you the -42 I'm after. When I combine, I get the -1. Okay, perfect. Those are my two magic numbers, so +6, -7. Okay, and if we were to FOIL this, or use the box method, we could check our answer. So let's just double check to make sure that that actually makes sense. X, 6, x, -7. So x times x is x squared. X times -7 is -7x. X times 6 is 6x, and 6 times -7 is -42. So I got an x squared minus 7x plus 6x minus 42, and when I combine those two guys, I'm going to get a -1. So yeah, if I multiply these two, I get this, which means these are the right factors. Okay. Now, if you're wondering, how do I get better at factoring? Well, there's a couple options for you. The first thing is you need to do a lot of multiplication. The best way to be a good factorer, or to be able to unmultiply, is to multiply. So I would recommend, if you're having a hard time factoring, that you practice multiplication of binomials. Pick out a couple binomials and multiply them, and just practice this technique. So part of this assignment, the purpose of this assignment, was to practice multiplying so that we can be good at factoring later. The other thing I would recommend is that you get good with your multiplication tables, because you have to look at a number like 88 and know what numbers go into it. You'll be like, oh, it's 8 times 11, or oh, it's 22 times 4, or something like that. So knowing your multiplication tables will help you be able to factor faster, because you'll be able to see those number possibilities in your head instead of having to figure out what the possibilities are every single time. Okay. All right, let's do one more of these, and then we'll go back and talk about the binomials. Okay. All right, let's take a look at let's do number 10. Okay. So first off, I'm going to set up my two binomials. My final answer when I factor should be like an m and an m, and there's going to be some numbers in here. Question is, what numbers? Okay, so I'm going to start by looking at my last term, -6. Okay, these two numbers multiply to that number. So that means one has to be positive and one has to be negative. That's our only option here. I mean, I could make negative positive, but it doesn't really matter. One's positive, one's negative, right? They can't both be negative, or this would end up as a positive number. They can't both be positive, because that would also result in a positive number. Okay. Now, also, I know that when I add them together, whatever these numbers are, the result is going to be a positive number, which means that this guy, the positive one, is going to be the one that overpowers the negative one. So its magnitude, or absolute value, is going to be bigger. Okay, for example, if I have 10 and -2, and I want to combine those together, the difference is 8, but the 10 has the bigger magnitude. It's farther away from 0. It's like we would say it's greater, but any positive number is greater than a negative number. So whatever the positive one here is has to overpower the negative so that our result is positive. Okay, so I got a positive and negative. I know this one's the overpowering one. In other words, like the absolute value, the number part, is going to be bigger here than it is here. Okay, I also know that they have to multiply to -6, and when I add them together, I have to get a 5. Okay, a positive 5. So let's try some stuff. So think about some things that multiply to 6. How about 2 and 3? Remember that one's negative and one's positive. So let's try -2 and +3. If I multiply these two numbers together, I'm going to get a -6, which is what I wanted. If I combine these two numbers, though, I get a +1, because a 3 and a -2 gives me a 1 right there. Okay, so that's not going to work. Okay, let's try the other way. Let's try a +2 and a -3. Okay, those will still multiply to -6, which is what I wanted, but when I add them together, I'm going to get a -1 now. Okay, so it's not 2 and 3. Those aren't going to work. So what are some other things that multiply to 6? How about 6 and 1? Okay, keep in mind that one of them is positive and one of them is negative, so let's try it this way. +6, -1. Okay, if I multiply those two together, I get -6, which is what I'm after. If I combine them, add them together, I get a +5, which is what I wanted. Okay, so our magic combination is +6 and -1. Remember that I knew the +1 was going to be bigger. And when I'd say bigger, really what I mean is if you ignore the sign, that's kind of like the absolute value. Which one's bigger now? The absolute value. So 6 overpowers 1. So when I combine those, I'm going to get a positive number out. Okay, so those are my factors. Now if we wanted to check, we could FOIL. You could use the box method or the FOIL method and just make sure that when you multiply these, you get this back. Okay, that's the check. This is the answer. And remember, this is like a backwards version of what we did in class. Okay, so that gives you kind of a head start on those trinomials, those 3-term problems. All right, now let's go back and look at some two-term stuff. So we got this guy right here, and this guy right here. Okay, so these are actually a kind of a special kind of results that we get. And let's take a look at our in-class to see when that happened. So notice I have 3 right here, and 6 right here, and then later I have 9, and all of these resulted in a binomial. In other words, 2 terms instead of 3. And one of the questions that we talked about in class today was why? Why does that happen to these ones but not all the rest of them? And if you go back and look at the originals, you'll see a pattern here. Okay, notice that this is the same number, 10 and 10, but one's positive and one's negative. Right here we have 7 and -7, and here we have 5 and -5. And so what happens is, somewhere in the middle of the problem, the -10 and the 10 like kind of cancel each other out. I mean, we have an x on them too, because when we FOIL, they pick up an x. Same thing over here. But what's going to happen is they're both going to have an x, so they're going to be like terms. And when we try to combine them, they're going to cancel out. Right? 7 and -7 like are additive inverses, and so we get 0. And 10 and -10 are additive inverses. And 5 and -5 are additive inverses. So what we observe is that whenever we get 2 terms instead of 3, we know that in the original factors we had additive inverses. In other words, we had a positive number, and then we had that exact same number but the negative version, or kind of like opposites, that will cancel each other out. Okay? The other thing we know is that this number right here is actually that number squared. It's like 5 squared, right? Because I have 5 and -5. So if you kind of ignore the sign for a minute, 5 squared is 25. 7 squared is 49. 10 squared is 100. So what we call these problems that look like this, we call these, these guys right here, these answers, we call these a difference of squares. Okay? So a difference of squares, difference means subtract. Squares means there's 2 things that are squared. This is x squared and this is 7 squared. This is x squared and this is 10 squared. This is x squared and this is 5 squared. Right? So whenever we see a difference of squares, we know if we backtrack, they came from 2 binomials where they had additive inverses inside, like a 5 and a -5. Okay? So, knowing that, let's go back to this assignment. Okay? So, look at some of the ones that I left out. 3, 8, and 11 are all differences of squares. Like that's x squared and that's 12 squared. That's x squared and that's 2 squared. That's n squared and that's 10 squared. So it's actually pretty easy to factor these because there's like a huge hint here. Like, look, it's only got 2 terms. The middle term, or the linear term, is not there, right? That's the linear term. The middle term has just the letter. It's not squared. And I'm missing that here, which means that I need a plus and a minus, and the numbers that go here are the same number except one's positive and one's negative. So you have to think to yourself, what number multiplied by itself is equal to 144? Well, it's 12. So if I put a positive 12 and a negative 12, positive 12 times negative 12 is negative 144. But remember that in the middle of the process, I'm going to have a 12x and a negative 12x that are going to cancel each other, which is why you don't see that middle term there. Okay, so a difference of squares binomial will factor to something like this, where you have the same number inside, but one's positive and one's negative. And it just so happens that that number is the square root of that guy. Okay, here's another one. So I know I have x plus, x minus. I know the number that goes inside is exactly the same. One's positive, one's negative. So I just look at that number right there, ignore the negative. What's the square root of 4? It's 2. So it's got to be x plus 2, x minus 2. That's the only way we're going to get the middle term to cancel out and still get a negative 4 at the end. Now, if you wanted to check, you can FOIL and make sure that that's actually the case. Over here, we've already kind of done the FOILing to find that pattern in the first place, right? So we know that this is going to result in an x squared minus 25. All right, over here, same idea. I see a difference of squares, right? This is n squared minus 10 squared, right? 10 squared is 100. Or in other words, the square root of 100 is 10. So I know my factors here have a plus 10 and a minus 10 in them. Okay? On this one, let's go ahead and just double check. So if you're having trouble factoring, I recommend that you practice multiplying. So if you're not sure how you got the right answer, if you're like, I kind of got it, but I'm not quite sure, go back and multiply and you'll see where that came from. Like you'll see that it actually works. So let's try this, right? This is my final answer, so I don't want to get confused there. This is the answer, but this is a check. If I multiply these, I should get back what I started with. N times n is n squared. N times negative 10 is negative 10n. N times 10 is 10n. And 10 times negative 10 is negative 100. So altogether, n squared minus 10n plus 10n minus 100, we can see now that these are going to cancel, ending up with that difference of squares that I started with. So the more multiplication that you do, the better you're going to be at factoring. And that's true whether you're multiplying polynomials like this, or whether you're just talking about numbers. If you got your multiplication tables dialed in, this will be much easier for you. If you understand how to multiply polynomials, this will be much easier for you. Students that typically struggle with factoring are the ones that have a hard time multiplying, whether that's numbers or polynomials. So go back and practice your multiplication if you want to be a strong factorer. All right. Thanks for watching, guys. I hope that helps. We will talk lots more about factoring next week, and we'll have lots more chances to kind of develop our factoring skills. So stay tuned for more factoring next week. Bye.